Welcome to Almost Here, Round the Corner Future Technology podcast with Richard Jacobs. Future technologies poised to transform our lives for better or worse are the focus of this podcast. Almost here means these technologies are now here and starting to be used, or just around the corner, from Bitcoin to artificial intelligence, 3D printing, blockchain, virtual reality, and more.
Hello, this is Richard Jacobs with the Future Tech Podcast. My guest today is Sahil Gupta. He's the co-founder and product lead of Soundskrit, Sound S-K-R-I-T. The website is soundskrit.ca. So Sahil, how are you today?
I'm doing great, Richard. Thanks a lot for having me.
Yeah. Well, tell me about Soundskrit. What's the premise of the company?
Sure. So at Soundskrit, we're essentially developing a new type of microphone that's inherently directional. So we've seen the emergence of a variety of different sorts of voice interfaces, whether it be, Siri on your smartphone, or now, the Amazon Echo and all these smart speaker devices that are showing up around the home. And all these solutions traditionally need to use arrays of many microphones to essentially listen into a specific direction and block out the surrounding noise. And we've developed sort of a new microphone technology that can achieve this with just a single microphone. So in just a single sort of chip, we can listen into a specific direction and block out the surrounding noise. And so we are essentially reducing the footprint of existing solutions and also preserving the audio quality. So when you start using a lot of different microphones and putting processing on top of it, you really degrade the audio quality. And so we're sort of, preserving that audio quality and reducing that footprint and cost.
So that's interesting. So the microphone has to first maybe lock on to a particular sound signature, and then it can continually search for that, and when it finds it, just filter out all the other noise besides it. Is that how it works, or how does it work?
Yeah, exactly. So if you imagine imagine I was holding a string between two of my hands. If I blew across that string, it's going to vibrate and it's going to move. But if I blew sort of parallel to that string, it won't move at all. So in that sense, you can get something that only responds to sound coming in one direction. Now, what's really neat is that we use these nano structures, these nano strings, that we can stack on top of each other. So imagine taking that same string and stacking multiple strings on top that are oriented in different directions. So sort of in a single package, you can get multiple outputs based on the direction of the incoming sound. And then by adding sort of a software layer on top of that, you can either sort of, add up all the sound in your environment if you want to get sort of an omnidirectional response, or kind of mix and match different sounds in your environment depending on your application. So
what led the founders to create this company and this premise? What was the need that you see that needs to be fulfilled?
Yeah, so, speech recognition works really well right now. But once you start adding noise or multiple people in a room, it really degrades. So I don't know if you have an Amazon Echo at home or something, but if the TV's playing, or you have kids or something in a different room that are playing around, it can get kind of frustrating to use these devices, because you kind of have to keep saying Alexa, 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 and it really struggles to kind of tell when you're talking. Beyond that, voice is sort of making its way into everything. So, now it's sort of in the automotive sector, people are looking a lot more at the user experience. Voice is the number one most complained about feature in automotive vehicles. There you have an environment that's super noisy because the engine of the car, all the noise coming from the road, and so it really degrades that experience. And those are just a couple of applications. Even with virtual conferencing now, people want to be able to sort of spatialize their sound and give you better audio quality when you have a lot of people in a room that might be talking on the side and whatnot. And so there's a lot of different applications that I think voice is becoming really an important factor for. And the solution right now, I think kind of falls short a little bit. Like I said, the footprints are kind of big, and really when I want to scale these devices down to smaller sizes, like for your phone or an Echo, they really degrade in quality once I try to scale it down and really fit it into these consumer devices.
Well, okay, interesting. Why do they degrade in quality if you try to scale them down? And what is the current state of the art that is not your technology? What does it look like? Is it an array of a whole bunch of little microphones packed together that interfere somehow?
Yeah. So the state of the art right now would be sort of like two microphones that pick up sound coming from everywhere, and you use some software. If I can get a little technical on you, I guess when you drop your frequency, the pressure difference between sort of your two microphones gets smaller and smaller. So the lower frequency I go, so more bass type sounds, the smaller that pressure gradient gets, and that pressure gradient is really what drives the membrane. So you have a mechanical element that moves in response to the sound, and that force that drives it begins dropping off significantly as you drop that frequency. So if you were to actually listen to the audio of a traditional directional microphone that's small, it can sound often quite tingy because you're missing out on a lot of that low frequency sound. The human voice, they say the fundamental frequency of the human voice can get to be as low as 70 or 80 hertz. So I think there's a lot of information in that low frequency range that you're not picking up on. And so what we're doing, it's sort of, it's fundamentally measuring a different aspect of the incoming sound. We're not measuring the pressure of the incoming sound. We're measuring something called the particle velocity. So it's kind of like more of like the air flow. And instead of sort of like, if you imagined a big wall and you had a sound coming at it, you kind of have this pressure force which is pushing it. What we have is more of a string where air kind of flows around that string, and it's that airflow around it that makes it move. And that airflow isn't subject to sort of these same limitations that you get when you're trying to measure pressure. Does that make sense?
Yeah, it does. It's really interesting. I remember when I was younger, people would tell me that bass sounds are everywhere, and higher pitch sounds are more directional in nature anyway to our ears. So it reminds me of that.
Yeah, and then the lower if I want a directional solution that can actually cut out some of the bass sounds, I need to make my microphone bigger and bigger. It's sort of fundamental to the wavelength. So, we licensed this technology actually from a university over in upstate New York, where the professor had been looking into the auditory system of small insects. And what he found was that, right now the way we develop microphones, it's sort of similar to like the human hearing system, right? We have two really big pressure-based microphones, our ears, which are very big and they're spaced very far apart, on either side of our head. And we try to take that same principle and we try to shrink it down into something like our phone. And then you start getting all these weird effects. And what he found is actually, when you look at the auditory system of a lot of small insects like spiders, crickets, some types of flies and things like that, they actually use the hairs on their body. So it's not sort of like a traditional ear like a person, but it's actually the hairs on their body. And they sense the air that's coming across that hair, and they're able to tell when they have predators approaching with very high directional accuracy and from very far ranges relative to their size. And so sort of inspired by that
really
idea,
cool.
He kind of developed this.
Very interesting. I'm glad you're able to explain some detail about it without worrying about giving away proprietary info. It's rare you can get that, so that's great.
Yeah. I mean, a lot of that work is it's published online, and it's also kind of protected with IP and whatnot. I do find this story to be quite interesting. It actually, some of the work originated from a bioacoustics lab where they're actually looking at how there's a jumping spider, and its predator is a wasp, and it can detect a wasp from meters away with very high directional accuracy. And as soon as the wasp gets close, it just freezes up and it stops moving. And what they found is it was actually the hair on the kneecaps of the spider that they used to determine where the wasp was.
Oh, very cool. Well, the hair on my kneecaps doesn't do anything like that. That's very interesting.
No, not quite.
Well, so how far along are you with the design? Is this product been used for various applications, or is it still experimental?
It's super early stage, so we sort of have a university prototype, kind of still at that level. We sort of have an initial demo that we've shown people where essentially we can have two people talking to our microphone at the same time, and we can simultaneously transcribe the speech of both people. And we do that all in hardware without any, advanced software, AI, or anything like that, like some people are doing. And now we're really fabricating a set of like MEMS chips that could actually fit into something like your phone. So the current prototype, is a little bit smaller than my hand, and now we're going to something about the size of 3 millimeters by 3 millimeters, so sort of smaller than your fingernail.
That's really cool. So this will be on board on smartphones, you think, and it'll be in all kinds of devices in the near future?
The end goal is the smartphone. Obviously, it's going to take a bit of time to get there. I think applications like conferencing, whether it would be, now there's some people who are working on like natural language processing, where it's essentially trying to summarize and take meeting notes of what's being said and sort of the discussion. And you could imagine using something like this, where size may not be a huge constraint, but you could still separate out everybody in the meeting room and pairing that up with some natural language processing to kind of summarize what was being said. I think applications like that could be interesting early on, things like the smart home devices as well. But eventually, yeah, we do want to get to the smartphone because that's where most of the microphones are sold to. And one sort of analogy I really like for the smartphone is, right now with my video, I can zoom in and out of my camera, right, when I'm taking a video. Why can't we do that with audio? I love music. I've been playing the drums my whole life, and sometimes I look back at some audio recordings of a gig that we had, and you listen to it, and we used to perform over at this bar near my school, and you could just hear all the crowd and stuff talking and all the side conversations, and the actual music itself you could hardly hear over all the noise in the crowd. But you could imagine when you're taking that video and you're zooming into the band or whatever you're really listening to, that the audio could kind of zoom in as well and block out that surrounding noise. I think something like that.
Application. Yeah, I think that's really cool, and I think this is a great application. I guess, I try not to be negative, but I worry about the surveillance aspect of it, that it can be used, let's say, when someone's speaking, a public figure, to listen to the crowd all at once, literally, and to hear chatter and for like surveillance purposes. It could be used in a public place and literally pick up all kinds of conversations that normally wouldn't be heard. Any implications there, any thought, or have you been approached? Do you think you may be approached by, a government or so, or an organization that wants to use it for purposes that you may think are nefarious?
Yeah, so, that's definitely a concern. One thing I will say, I think with, that sort of can be the case with a lot of really new and great technology where, there's a good side of it, and then sometimes kind of people take it for their own, I guess, agenda or use cases. We did have somebody from the government approach us just to kind of see where we were at and things like that. And you could imagine using it to kind of listen into people. I know that's one big skepticism or I should say barrier to adoption that people have for devices, even like the Echo, right? Where people don't want, talk about the always listening devices in your smart home. They don't want somebody listening to them all the time. Stuff like that, if it's going to happen, I kind of feel like it's going to happen. What we're looking at isn't so much on that type of application, but more the consumer application and the user experience of it. Someone's going to take your technology, I guess, and kind of repurpose it for their own agenda.
People could always listen back too. So if someone's going to listen to you, you can listen back to them. It could be used both ways.
Sure.
So it's just something that came to my thoughts. So I wanted to bring it up, and it's something that you may have to deal with a lot, or hopefully not very much. I know you want to use it for good reasons, but like you said, all technology can be used in different ways. We
haven't had that concern too much, I guess, from people that we talk to. Granted, we're more of a B2B play than to the consumer itself. But when I think about all the other things that are happening around, like your home, for example, too, there's now people using like Wi-Fi or existing cameras around your home, and you can get a lot of information from those types of signals as well. I think there's a lot of ways that privacy can definitely become an issue. But it's not something, I think also just the fact that we're quite early in what we're doing, it's not necessarily a concern that's been brought up too much to us at this point. Yeah, well, let's move into other more interesting stuff. What about hearing things that you've never heard before? I don't know when this would occur, but if you're listening to recordings using your microphone set versus traditional ones, I bet you that you'll hear things you've never heard before. I don't know what they are, but there'll be background noises or other noises that are not present.
So, I mean, for instance, let's say you listen to a machine run, like a pump or some other kind of machine. I bet that there'll be a diagnostic aspect to this where your microphone, because it picks up sound differently or more finely, that you'll be able to diagnose things. Let's say, again, a machine, if it's running right or not, or some other background noise, you'll be able to tell something, or a person's voice, you'll be able to tell more of what's going on because you can analyze it differently, that kind of stuff.
Yeah, absolutely. So on the machine example, I mean, people are already doing this to some extent where they're using really big arrays of microphones to listen into different machines. Like, let's say I'm designing a new powertrain or something like an engine for a car. I want to make it as quiet as possible. So when you want to go and test that, you could imagine using a microphone array to actually localize where certain sounds are coming from, and then use that to actually improve your design and kind of use that as like a feedback loop. I think where we would come into play here is really trying to reduce the size of those arrays, which could be really costly, and also try to give you a little bit of a better precision on where those sounds are coming from. I think with autonomous vehicles, it's kind of interesting too, right? Because what happens when there's no one in the car? Who's listening to the car? Or even if you do have people in the car itself, you can imagine using something like this to tell you, not just listen into what exactly the sound is, but where it's coming from, right? So, you might be in a car and you hear some sort of squeak or rattle that's a little bit concerning, and, the microphone could tell you, is it coming from the passenger seat of the car, or is it coming from the engine? If it was coming from the passenger seat, maybe you could ignore it. But if it's coming from the engine, you might want to get that checked out sooner than later before it becomes a bigger problem. So I definitely think there's that aspect.
Knocking sound in the engine type thing, yeah.
Yeah, absolutely. And that's sort of one angle on that side. But I think, more on the consumer space, I don't know if you've been following anything about like sort of the hearable devices that have been coming out now. Google, they came out with sort of the Pixel Buds, which can translate what somebody's saying to you, and then, into your own native language and vice versa, right? So you can actually have a discussion with people who might not speak English, for example. Or there's one startup, Doppler Labs, which is looking at making hearables that could actually kind of fuse sort of the outside sounds with what you're listening to with your music. So, like as a simple use case, let's say I'm blasting music on my headphones or my earphones, and I'm crossing the street, and there's like a siren or an ambulance that's coming really fast. Well, what you could imagine using this to essentially reduce the volume of your music and then boost up the volume of that siren or that incoming car, right? So kind of give you more situational awareness and kind of make that experience a little bit more blended, I guess.
That's really interesting.
Yeah.
I thought that they would take the sound of the siren and make it part of the music you're listening to. But it's more useful to do what you're saying.
Yeah. And even beyond the sound itself, I think the whole hearable space is interesting too, because people are putting biometric sensors into hearable devices as well. To be honest, I don't know how mature this technology is right now, but I have talked to some people more at a research standpoint who are looking at putting like electrodes onto your hearing devices, right? So it could actually tell what where your attention is, right? So imagine I'm visiting a new city, and they have sort of those walking tours or those bus tours with the audio kit. But now imagine if you could personally, like, you could tailor each of those experiences based on the specific person and where they're looking at. So you could actually get some feedback. Oh, they're looking at this structure here. Let me actually tailor the audio and sort of that tour and experience to what really interests them, right? Instead of just having the same thing for everybody.
Yeah, that's really cool. Huh.
Yeah.
I like this. As I get more into it, I can think of more and more uses, and you're telling me more and more uses for it. It's really cool technology.
Yeah, and those are, I guess, like a little bit more fun applications, but the research itself was funded by the National Institute of Health for hearing aids. So one of the biggest complaints of hearing aid users is that they don't work well in noisy environments. Actually, it's kind of funny when I released the website. I never expected it, but I got a couple calls from people whose parents were using hearing aids, and they were kind of telling me how something like this could really change their life, because right now they can't even go out into noisy restaurants and bring their parents out into those types of noisy settings, because it just kind of amplifies everything right around you, and so you don't know what somebody's saying that you're actually trying to converse with. And part of the reason is that you're taking, again, like 2 of those pressure-based microphones, putting them really close together because you want to make your hearing aid really small, and they're just not very good at rejecting noise and kind of picking out that sound that you want.
I wonder how this will interact with white noise. If there's a use to amplify it or produce it, using this system, or filter it out. That'll be interesting. I have a fan on in the background, for instance, so that's what brought it to mind. Any thoughts there?
Yeah, you could definitely in software kind of filter that out, right? So especially noises that aren't moving, like when you have a person that's moving around, and speech, which the spectrum, I guess, of the speech really changes. It's a bit more difficult to kind of filter out. But if you have something like a fan, it's always in the same place. It's very constant and it's very predictable. So yeah, you could definitely filter that out. I think devices already, like the Amazon Echo and Google Home and smart speaker devices like that, they do that to some extent already. Okay,
very interesting. So what's the rollout plan? When do you think that your device will be in use, and where will it go first, and when?
Yeah, so the hope is sort of to have like a product ready type device, maybe by the end of next year, mid to late 2019. And really what we're looking at is sort of like OEM plays, and so hopefully we can get that to the point where we can actually get sort of a design in with an OEM, and then from there, hopefully over the next 2 years, I guess would be a sort of typical product cycle for consumer electronics, try to get that actually integrated into a device. So it could be 2-3 years out, I guess, before it actually gets into a consumer device itself.
Yeah, but it'll be soon, so it's definitely coming soon, which is good.
Yeah, that's the hope.
Yeah, what's the best way for listeners to get in contact? Ask questions, collaborate, propose solutions, that kind of thing?
Yeah, so you're welcome to check out our website. Right now there's not a lot of information on it, but we're revamping it right now, hopefully to give a bit more information. I always love talking to people who are interested in the tech, just to kind of see where their interests lie. And sometimes there's sort of a limited amount of use cases I guess I can think for it. I'm sure other people have great ideas for it too. So my email, it's just my first last name, Sahil, Sahil, .Gupta, Gupta, at soundskrit.ca. So my email's on the website and everything too, and if anyone wants to learn more and reach out, always happy to talk more about it.
That's great. Well, Sahil, thanks for coming on the podcast, and I love what you're doing. It's really interesting.
Thank you so much, Richard. I really appreciate it.
You have been listening to Almost Here, Around the Corner Future Technology podcast with Richard Jacobs. Subscribe to this podcast, post a review to discover more future technologies that are poised to transform our lives for better or worse, such as Bitcoin, artificial intelligence, 3D printing, blockchain, virtual reality, and more.